Hello and welcome to Learn Synthesis with Pure Data, Season 1, Episode 8. In this episode, we're going to be making a filter for our synthesizer and see basically how this subtractive synthesis approach is utilized in synthesis to make sounds more interesting. Okay, so we're going to add another module to our signal chain in our synthesizer that we've been making. And this module will basically filter sound. In other words, take out frequencies that that we want to in order to shape the sound a little bit more. It's a rather major part of sound crafting in synthesis, so it's an important thing to know about. And so let's get right to it here. Should have minimized that first. But anyway, here we go. So, yes, we will get to this amp mod module later. I don't know if it's next week or the following week, but we will get to it and put it in our signal chain. Today, what we're going to do is add another module right about here. Now, this module doesn't need to be as wide and so forth, but we are going to be crafty in naming it. You notice how we have OSC1 for our signal generating oscillator, and we have ADSR1 for our envelope. This is amp mod. It doesn't have a 1 behind it because we'll be using it for this signal chain here, but we will be in the future adding another chain, and we'll basically be duplicating these modules and making them OSC2 and ADSR2 in the future, so that we have another signal chain to work with. And I'm already planning that this filter is going to be something that we'll duplicate and put in that signal chain too. So I want to name it and all its internal sends and receives with a 2 behind it, so that you'll see later when we do that duplication, so that we don't have any confusion. We'll basically have these being independent of the modules we'll be making down here. So I'm going to name it PD filter _1. And as you see, a new patch window comes up. This is our child patch. This is what's going to be in here. Now, what I'm going to do is we need to open up some of these other modules so that we send signal here and then have it send signal here. And while we open these up, I'm going to look at the size, try and keep it in line. It doesn't need to be as wide as the, it's going to be a more narrow module, but having it being the same height would be nice because it'll just look nicer that way. So I'm going to right click here, look at properties to see what the size is for the graph on parent region of this module. All right, 170 by, is that 250 or 260? Okay, so I'm thinking maybe half the size. And so that would be 85 by 260. I'm going to try and remember that. 85 by 260. Now, the signal from this oscillator is coming out here. OSC1 out. Actually, that's a perfect name. But what we're going to need to do here, and temporarily we won't be able to hear anything. Right now, the synthesizer does play. So sometimes I need to unplug my MIDI controller, replug it. Get this to respond to it. Let's just check and make sure I have the MIDI hooked up. Launch key, yeah, I'm using. There we go. Just sometimes you need to, what do you call it? Unplug and replug the controller just to get it to wake up. So anyway, I'm going to right click here on the ADSR, open it up. Here's where the signal's received. It's receiving OSC1 out. Let's change this to filter 1 out. Because we're going to put the filter right between the oscillator that generates the signal and the envelope. So let's open this up then. Okay, so we're going to be, first of all, let's make the graphic region before I forget those numbers. Graph on parent, and its width is going to be 85 and the height 260. I'm going to hit apply, and there you see, since I have the window open, it's grayed, but I can see right height, about the right width for our purposes here, because we're just going to have 2 vertical sliders in here. And of course I'm going to be explaining what filtering does. First, we're going to need to receive our signal in, so we're receiving from oscillator 1. R tilde, remember we're receiving an audio signal, so it needs to have a tilde behind it. Receive OSC underscore 1 underscore out. So this is where the signal from this module is coming into here. And then we're going to send out from here S tilde filter underscore 1 underscore out. That's what's being received by the envelope. So if we hook this up to this directly, we should hear sound. Test that. Okay. Now for filtering, sine waves are not something you want to filter. And that's what the sound is by default in the synthesizer. Because a sine wave is one pure tone at one frequency. And filters are used to shape the frequency spectrum. So you need a richer frequency spectrum to do that. Triangle wave would work, but we wouldn't hear as much. We'll hear filtering better. That's the square wave. Here's a sawtooth. The sawtooth is the richest. And so that will allow us to shape the sound better because it has a richer spectrum of frequencies. Okay, so now what we're going to do, take this line out now, and we're going to put some filtering in. Now, there are a number of different filters in Pure Data. And what we're going to use is an object called VCF tilde. I'm just going to leave it like that. Without any creation arguments, it has 3 inlets at the top. It has 2 outlets. And we're going to look at its help file here. You can do with just about any object to remind yourself about it. Now, its inputs. Here they have it stretched out a bit. You can go to the right of any object in edit mode and you get this arrow which you can click and extend the size of it. But basically, through its F-lit inlet, and this it can receive at the audio rate. And what that is a signal to be filtered. It comes out. So this is where our signal will come in. Then this is the frequency at which the filtering is going to occur. Now this object does 2 types of filtering. It does band pass, which means whatever frequency you set here, that's considered to be a center frequency. It will pass frequencies around this center frequency. Like it'll pass this frequency and frequencies a little lower, a little higher, depending on how wide you set this, the 3rd inlet, which is called the Q. And this is terminology that's utilized standardly in synthesis. Now, sometimes the center frequency can be called a cutoff frequency for different types of filtering. Like sometimes, now here you'll see it emits a low pass signal. What that means is anything that is below this frequency will then be passed through. So this basically attenuates and eventually, like in a curve, it'll attenuate and eventually cut off higher frequencies. So that's why it can be called a cutoff frequency. Sometimes if you have a filter that is one or the other, like band pass or low pass, for the band pass it'll be called center frequency. For the low pass it'll be called cutoff frequency. But either way, it's a frequency where you determine what's getting filtered. Now, the Q, as I said before, when you're doing band pass, will decide how wide of a range below and above your center frequency will come through. The Q will affect the low pass differently. It'll basically be the slope of cutting off the higher frequency. How steep is the slope where it cuts things off? Okay, so we're going to then work with that. Okay, so let's take our signal in because we're going to hear these things and actually arrive at some settings that will be beneficial for us. And then we'll set up some sliders to adjust our parameters. But I want to listen to them first to get like the range of values, numbers in other words, that we want to put in here, be able to control this. Now, I'm also going to look here. I'm going to open this up. Right here, we're getting, after our pitch bend that we added last time, this is going to be the frequency that these oscillators are going to be sounding at. It's good to have this frequency value. So I'm going to set up in here another send. Send. And let's just call this frequency, I'll abbreviate it RFEQ _1. Because this is oscillator 1 and we want to be able to do the same thing with a second oscillator when we add it. So what's getting sent to the oscillators here is now going to be sent to this window's already open, so I need to go down here and find it. There we go. All right, to here. We're going to receive and we're going to say frequency freak 1. So we'll get this coming in here. Don't forget the tilde after the R, because it is audio rate information that's coming in. So here's where we'll get the actual frequency being played, including the bend. So if it's being bent up or down by the pitch bend, that's also part of this. That's what this value will be. So what this does is this is telling us, and this is helpful, what frequency is currently being played. So it gives us a good indication for center frequency especially. Now, a lot of times though, you don't necessarily want it to be exactly your center frequency. You may want to be able to adjust it. So what we're going to do is put in a slider here, a vertical slider. V. There we go. Control-Shift-V, Command-Shift-V in Mac. I'm going to right-click on it and go to its properties. Its range by default is 0 to 127, which is good for MIDI stuff, not for us. Now, to make this useful, it would be nice to be able to bend, for it to be able to go below the frequency being played. Well, not so much, because then if you're filtering out stuff down there, there's not really anything there. Your frequency that's being played is really going to be your fundamental, and all the frequency content of your waveforms are going to be overtones, harmonics and partials. In this case, harmonics, since that's what we're generating here. So it'll be those harmonics above the fundamental. So we want to be able to maybe control how far above that frequency we want to set as a center frequency or a cutoff frequency in the case of low pass. And so what I'm going to do is make this a range of 0 to 1 for now. Now we have a little more room here, so I can make this taller to give us a bit more resolution to this slider. Now why 0 to 1? You'll see in a bit. 260, let's make it it is 260 tall. Make it 200 tall for this. And we're going to give this a send and receive symbol. I'm going to start off by typing filter 1, just like in the other modules. I want my send and receive symbols to include in it the name of the module and the number of the module. So that way later, as I spoke about earlier, when we duplicate things, we'll be able to duplicate this, change the number, and it'll automatically be independent. And the sends and receives won't be crossed with one another. So filter 1, this is going to be our frequency slider. And this is the send. And here I'm going to put filter underscore 1 for our FREQ underscore receive. I don't know that it'll be receiving from anything, but I always like to put receive symbols in just in case. Okay. And its label, because it's a narrow slider, I'll just put F at the top. That should indicate to anyone that sees that it's a filter. The letter F obviously means frequency. Put it there for now. Okay. So now I made a range of 0 to 1 because what we want to do is be able to control basically how far above the fundamental frequency we want to set our center or cutoff frequency. And so, first of all, what we need to do is take whatever frequency this is and subtract it from 20,000. Thinking that 20,000 would really be about, it's the highest point or the highest frequency our human ears can hear. In fact, most of us don't hear up that high. Maybe I should say 18,000, something like that. You probably don't really want to have it all the way up there because you'll be cutting just about everything out that you can hear. But, to give us some values to start with in our experimentation here, we'll start with that. So, now how do we do this? Well, I'm thinking of a mathematically simple way of doing it. Like if we want to subtract this from 18,000, now this is coming out at the audio rate. Okay. Well, actually, what we want to do, all right, let's do this. 18,000 in a message box. Or actually, no, we're going to do it like this. Swap 18, 1, 2, 3. Now remember what the swapped object does. Whatever you have as a creation argument, or whatever comes in the right inlet comes out the left outlet. Whatever comes in the left inlet comes out the right outlet. I'm going to put a receive here. Filter underscore 1 underscore freak underscore send. So that's the send symbol from the slider that we just made. That will come in here. And then what we're going to do is have it then have a multiplier right here. Now, why am I using swap? Well, remember that whole thing where values received through the right inlet don't necessarily calculate? Well, swap takes care of that. Because when something comes through here, we move this slider. It'll come out here, the right outlet. But it'll always come out with the 18,000 coming out the left outlet. In other words, it makes the star here, the multiplication symbol, or object, actually. It'll make the multiplication object actually multiply. And so we will constantly get values. So watch this. As I move the slider up, I'm in run mode now so that I can move the slider. You see, all the way up, we get 18,000. Down here we get 0. And now what we're going to do the value that comes out there is then going to be added to our fundamental frequency. But this is at the audio rate, so we do need a plus tilde. So here's our frequency coming in here. And we're going to be adding to it how much between the fundamental frequency. Well, when we add this to it, it's basically going to be changing this frequency by how much of a range between this and 18,000. But now I just thought of something. What if the frequency is higher? It'll push that 18,000 well above the frequency spectrum. Okay. What I need to do is actually determine how much lower than the frequency spectrum this is. That's right, I wanted to subtract this from this. And then multiply it. So let's get this out of here, actually. Sorry about that. But as I rethink this process, hopefully it's making sense and reinforcing the concepts. All right. Now I can make a minus tilde. Well, a minus tilde. And have 18,000, move this over. Come on. It made it down below. Okay, have 18,000. Make sure it's load banged because we want this in here to begin with. So 18,000 will be subtracting, or we'll be subtracting from it whatever this frequency is. Now, since it's audio rate, the right inlet will continually be receiving values from here. We don't need a trigger or anything to do that. So there, we'll be getting what the difference is. And then that difference, meaning the range between, let's say this is 440. Well, then that means 18,000, like our max frequency would, the difference would be 18,000 minus 440. That's 17,560. That's what we want to be multiplied by the range of 0 to 1. So this is going to have to become one of those, a star tilde, where this value gets multiplied. Now, as this value streams in, as you move the slider, once again, we have that thing where some of that could be jumps and we'd hear artifacts or snapping sounds. So we're going to smooth it out with our good old friend, TAC F50. And line tilde. So the signal will be smooth. Okay. And then this result is what gets added to this frequency. We'll take a second line from here and then add this result to it. And then that will go into our center here. Now, the thing is, we do need a Q value to start. And what I'm going to do for now is just make a number box and experiment with some Q values. Oops, it went to the wrong inlet there. Make sure it makes it into the rightmost inlet. There we go. And let's give it a value. We do want to hear this eventually. Right now, we probably won't hear anything because it ain't done yet. So let's see. I'm going to put in a value of 20. From what I remember, that's a pretty good value for Q. Okay. We need to send this 18,000 through, so I need to click it now. In the future, it'll go through when things are operating. I need to play a note. Now I'm going to move this up. Right now, what's being passed is a frequency range a little below and a little bit above the fundamental. What would actually work better, since we don't need this stuff a little bit below the fundamental because there's no frequencies there, it's better to use this as a low pass. And in fact, the low pass filter is very common, especially in simple synthesizers, the more common of the two. So let's try that. Yeah, and in fact now it's sounding like a sine wave because we are cutting off all these higher frequencies that make the sawtooth sound like a sawtooth. Now let's raise this slider. Now it's getting quieter and quieter as I move it up because it's cutting out more and more of the lower frequencies. Let's experiment with some Q values here. Let's try half this, 10. It's expanded our range here, but probably, meaning, because this governs the sloping off of the cutoff frequency to where it totally cuts things off, and then actually we're not hearing it totally cut things off. It's attenuating a lot, but what I want to do is to get this interesting range here to be wider, and I think I can do that with Q. Let's make it 1, for example. That's too steep. Here it's cutting off here. See, it's cutting off at the same point, no matter how high I play the note, because this stuff here is adjusting. It's applying what we call keyboard tracking. As the frequency gets higher, the cutoff frequency gets higher too, in proportion with it. So, okay. Now, try something like 5. Thing is, this stuff up here there isn't much interest up here. So I'm thinking, first of all, I'm going to change this to 10,000. See what that does. Now, what I'm going to do then also is make this steeper, put it back to 1. Now it's cutting off here. Let's try 2.5. Okay. I'm thinking about this a bit. Even though the center pass or the band pass does have that thing where it passes things below the fundamental. Which we don't need. I was just seeing if it made a more interesting. Sound change. I'm going to put this back to 18,000. What I'm going to do maybe change the range of this. 0.25. Try that. Because this is where I was hearing the most interesting range was down here. And that's where I'm getting the more effective timbral changes. A good, nice long selection of interesting values. So that seems to have worked out better by doing that. Now let's see if we can find an interesting range here. Try 1 again here. Try 2. Try 10. Try 20. Try 40. Let's try 50. Okay. 10 again. All right, this is what I'm going to do. I'm going to make another slider. I'm just going to duplicate this one for now because it's the right height. Oh, looks like we made some empty object boxes there. Let's duplicate it. And this is going to be our Q slider. So its values right now, I'm finding 10 through 50. Be interesting. Filter one freak. Let's change freak to Q. There we go, and change its label to Q. So now this will be our slider for controlling the Q. Put a receive in here. Receive filter underscore one underscore Q underscore send. Okay. Now let's leave the cutoff there and then change the Q. Okay, so what we're hearing as we increase the Q is more of a focus on that frequency. It's like narrowing the band. And so, in other words, the area that's being passed. Let's hear this as a low pass, which is what I originally wanted to use as my filter. So this is supposed to be the low pass outlet. Now, let's see here. I'm going to make the range even wider. Let's have it be 10 to 100. Try that. No, that's most of that range doesn't really do much at all. I remember in the past I did things like this. 0.01, let's say up to 20. I was just trying things out again. All right, too low of a value. Let's make it 1. Now the shame is that the Q can't be sent in as the audio at the audio rate. And that's unfortunate because it'd be nice. So you don't hear the little scratchy sounds in there, the artifacts. But in any event, let's put the Q to somewhere there. Okay, now I'm going to check something else out. Mostly hearing scratches towards the bottom of the range. So maybe make this 5 to 20. See, as we raise it, it basically is narrowing the Q down, and that's why it also sounds quieter. So I'm going to make it a range of 1 to 100, 5 to 100. And then what we need to do is amplify this a bit. So this is how we're going to do it. As the Q goes up, I want it to increase the level coming out. So what I'm going to do here is make a multiplier times 0.01. Actually, 0.005. Now let's receive this Q here as well. We'll be constantly multiplying by that amount, and I'm going to have that added to this. So let's put a plus tilde. No, times tilde, not added, multiplied, because we're amplifying, and that's multiplication. Do that. Now we want these changes to be smooth. Since this is not audio rate, we'll hear artifacts unless we smooth this out. So I'm just going to copy these things from up here. And put them right down here. And this will be increasing the amplitude as I narrow the Q. Let's see if it sounds right. Everything's too quiet. Okay, so my values are not probably 0.01. Because since this is a range of 5 to 100, right? We'll make it adding a range of 0.05, 1. Now the 1 might be a little much. I think this range is too wide. That's one thing, which means I'll have to adjust the amplifier again too. But let me look at the help file here for the Q. See if it gives me some suggested values. Filter sharpness is still only set by message. Yeah, see here it's listing BP, like the bandpass filter. This is more expressive because the bandpass doesn't have a Q. And I don't think the frequency can be set at the audio rate, so it's not as smooth. But it doesn't really give me values that are let me see how these go down. Uh-huh. See, this is giving me like an envelope output. This is telling me the outputs from both of these. The output from the low pass does seem a little stronger. Alrighty. Yeah, my Q range isn't exactly the best. Let's put this back down to 20. I'm used to like an analog synthesizer knob where the Q really does a lot. Now let me see here. Maybe I should. This is what I've always done in the past. Is 0. Let's try 0.1 up to 5. Mm-hmm. Oh, it's up to 20. Yeah. Okay, so yeah, the total length of this probably isn't all that necessary, but I am going to definitely change this, 0.1, see how that works. As you see, you can get like a lot of timbral adjustments here. I was just trying to get the here. Let's make that. Now, if you put it all the way up, like if we load bang some values, because we do want to have some default values. I think some good starting values for these would be to basically have them off, which would be having them at their max. I'm going to try 50 again on this, just to see. I'm sorry. Let's just see here. No, yeah, that extra range is not necessary. So let me go back here again. Maybe I don't even need to go above 10. Yeah, 1 to 10 seems to be giving me about as much change as I get there. So anyway, I'm going to make default values, make a message 10, make a message 1. Remember, the left slider for frequency is a range of 0 to 1. And the right slider is a range of 1 to 10. Okay, so that will be their defaults. So when the patch opens, that's what they'll be at. Let's close this. Now move this over. There's going to be one more step to this, but right now I'm just cleaning things up a bit. This MIDI input module I'm going to make wider because I'm going to add another controller now. So what I'm going to do is open up this MIDI input module. And let's extend its width a bit more. Now its width at 350, which is like two 170s put together. So I think the regular width of those things. I'm going to make it 700 wide because we're going to be adding more stuff in the future. Maybe. Let's see. Let's make it as wide as the modules that we will have. Yeah, because we are going to even have a little bit more over here. So there we go. Yeah, 700 seems to do. Allows me to space these modules apart here. Have this go almost all the way across. What we're going to add here is mod wheel control. Typically, controllers will have, MIDI controllers, if they have knobs and sliders on them, they tend to have a lot of different assignable control signals that you can set called continuous controllers on different controller numbers. But one thing that just about every keyboard MIDI controller has is a mod wheel. Modulation is MIDI controller number 1. And most controllers have one. And that's typically used to control, although sound designers could have it control any aspects of the sound they want. It's frequently used to control the cutoff frequency. In this case, center frequency, cutoff frequency, controlling your filter's frequency. So I am going to make another horizontal slider here, right next to pitch bend. I'm going to call it modulation, capital M, 0 to 127, the MIDI range for this controller. And we're going to call it MIDI modulation send, MIDI modulation receive. Okay, and so we're going to set up another thing for this. Like here we have bend. Here we're going to have CTL in 1. That means receive MIDI controller 1. And so what gets outputted here is that controller's value. And that's the default for all modulation wheels, is controller number 1. So here's where you get that value that your mod wheel's at, which could also be a touch strip these days. Or here would be, and here would be the channel. So because we want to be able to select the channel and open and close a spigot, I'm just going to copy this over. Like that. And all this goes back to when we made the MIDI input module. Okay. And then we need to have the channel go into the right inlet of select there. So that way the user can change the channel that this synth receives on. And then away you go. And this will send MIDI modulation receive. So this basically is sending it to here. So when you move the modulation touch strip, or modulation wheel, it should move this. Now I have a touch strip one. All right, it's not doing it because since I just made this, the one never got sent. But I could either click on it or go up here and just type 1 here. I'm on MIDI channel 1. There we go. Now it responds. Spigot needed to be opened. In the future, it will open automatically because this 1 gets load banged through. Now, if your MIDI controller is sending on a different channel, then it doesn't work. My pitch bend back. There we go. So that's our MIDI modulation. It's coming through. Now we need to go back here. And what we have here is usually you want it to control your frequency. The Q isn't a huge effect, so that is something that I would, just set manually with the mouse cursor. But we could have this control frequency. And so what we'll do to do that is receive MIDI modulation send. Now this is coming in a range of 0 to 127. Move this over so it doesn't get cluttered there. So we need to convert that to a range of 0 to 1, which is the range of our frequency slider. So we divide by 127 to do that. And that gives us a range of 0 to 1. Now I'm going to save close. Let's zoom out. Now, your modulation wheel will typically be down on your controller. I'm trying to think here. The upper half of it is not giving me much. So I might just go back here to here where it's doing the whole spectrum, and instead make this 10,000 again. Cut it basically in half. Now let's see. Might even be able to lower that some more. Let me just try. I mean, because the whole idea is you want your effect to be something where when you go throughout the range, it's actually doing stuff. It seems like in the upper part of the range, because the frequency spectrum is exponential in nature. Let me adjust the Q here a bit. Gotta be in run mode. Oh, that's the pitch bend. I was like, what? It would be better if I was able to, rather than have this be so linear in, sorry, I opened the wrong module, to have it be exponential. Now that can be done. I'm just wondering if it could be done in a quick way. I could set up a table with an exponential curve in it and have the index of the cable go up and down it, but that would take a bit and be annoying. This didn't, lowering this number didn't seem to help much. I'm going to put it back to 18,000 actually. Right here it's multiplied by this linear value coming in. I remember here it is. Let's change this slider instead of linear to be logarithmic. So I hit that LIN and it became log. Let's try that. Now, I wonder if the mod wheel, yeah, the mod wheel's just jumping up and down on it. Yeah, that is actually giving me a better throw on it, but I'm going to probably have to do the same thing to the mod slider. Here, let's try it on this guy as well. That is sounding better. Giving me better of a range there, or control throughout the range. Let's go in here. I'm wondering if some MIDI controllers you can make logarithmic. Let me see here, because if I do it with the mod wheel now, you see it's not working as well. But let me see if I change its slider that way. No, because the controller itself is not logarithmic, so I can't do this. I would have to make a table and so forth. But at least this explains the concepts, and it gives us a pretty good control over it. But what I'm talking about here in trying to get this thing a little bit more, better in control. What logarithmic would be is, instead of you moving this up and the actual results coming out in a linear fashion, like evenly spaced apart as you go from up to down to up and up to down, you would be getting a curved result. Instead of it being linear straight line up and down, it would be curved, which actually works better with the frequency spectrum. It is curved. So but using it with the mod wheel, what I'd have to do is set up a table that has a curve on it, and then what it would do is the actual mod wheel values coming in would read through that table that has a curve on it going left to right for up and down, and read the value in the curve as opposed to just a linear value. That would be the way to fix it, but it would take a bit of work to get that, and I don't really want to do it. But this explains the concepts, and actually we do have a pretty good setup here. You could even have the cue controlled by a different MIDI controller. Now let me see here. Maybe even have the cue controlled by the same controller. See how that sounds, and this will be our last step, just to see how it sounds. Now, cue, different range. 1, 10. So since we'd be getting a 0 to 1 out of this, multiply it by 10. Now the 0 would not be allowed to happen because it's, because since the slider has a minimum of 1, it wouldn't let it go to 0. 0 would actually cut out the sound, so we don't want that anyway. But the slider will apply that limit. So let's just see what happens. Move my mod wheel. Whoa. The slider should be keeping it from being a 0. Oh, I'm multiplying a 0 to 127 by this. Oh, geez, no. Yeah. I need to come out of here. Oh, yeah. Every now and then I hit the pitch bend. That's what that's. But it's shutting off, so it is allowing the 0 through, isn't it? Well, what I can do is this. Let's put a Moses on it. Moses 1. So anything that's, let's do that. Since we want it to be able to go down to 1, we'll say 0.99. So anything that's 0.99 or below goes out the right outlet. Everything else goes out the left into the slider. That'll prevent anything below 1 coming through. Oh, no. It's the opposite, man. What am I thinking? The left side is anything that's below 0.99. The right side is 0.99 and above. There we go. There we go. So there is our filtering. That sounds pretty good. Now, a lot of times what you can do is have like this cutoff controlled by another envelope, where the attack, decay, sustain, release then also controls the shape of this. That would mean making another envelope and running this frequency signal through it instead of amplitude, but basically in the same way. But I'm not going to do it. This is enough for explaining the concept. And I'm going to take a screenshot. And I'll thank you for watching. And please hit the like button if you can. And if you haven't subscribed already, please do. Help the channel out. Gotta spread synthesis around the world. Plenty more stuff coming. I know we're just in the basics right now, but I gotta cover the basics before you can get on to the more complicated stuff. As we do, it'll be an adventure to behold. Thank you for joining me, and take care.